Newton's first law of motion states that a body at rest remains at rest, or if it is in motion, remains in motion at constant v unless acted on by external force. So this is the Newton's first law. So let's take one example. Consider a ball rolling along a rough surface. Say this is a ball rolling on the surface, rough surface. It will stop after some time. So it will stop here because there is an external force here. This is friction. Friction here is the external force that makes it stop. Okay. Say we consider the situation. If there is no external force, if we assume there is no external force, it will move forever. Move forever. Okay. Move forever. So this is the important concept. If there is no external force, either it will be at rest or continue to move with constant v. So for example, again, if it is rest, if no external force, it remains at rest. If it is in motion, it keep moving with constant v if there is no external force. External force makes the object to stop. Okay. So Newton's first law is also called the law of inertia. The inertia is the property of object which remains at rest or continue to move at constant v. Okay. So inertia of an object is measured by its mass. So the greater the mass, the greater is the inertia. For example, it is difficult to start the motion of a large stone than that of a ball. Mass and the weight are not the same thing. Roughly speaking, mass is the measure of amount of stuff in something. Its SI unit is kilogram. It remains same everywhere, so it will not change. The weight of an object keeps changing. Okay, and this is so weight is the force exerted by Earth on the objects. So let's take one example over here. Say weight W equals m times g. So here W is the weight, m is the mass of the object, and g is the acceleration due to gravity. Acceleration due to gravity. Let's say mass is, I just take an example, 2 kilogram. So at Earth's surface, the value of g is 9.8 meter per second square. This is the average value. Then the weight will be 2 times 9.8. That will be equals to 19.6 kilogram meter per second square, and 19.6 kilograms meter per second square is called the Newton. So this is the weight at the Earth's surface. Okay. Let's consider a situation. This is the, say this is the Mount Everest peak. This is the Mount Everest. This is the sea level. Down is the sea level. The value of G at the sea level, say G1, and value of G at Mount Everest is, say, G2. Then value of G will not be the same. So G2, which is the value of G at Mount Everest, is less than value of G at the sea level, which is G1. Okay, so value of G will be different. So the number we are always talking about, this number is the average value. Average value of G. Okay, let's talk about the another situation at moon surface. The value of G is roughly 9.8 over 6 times less. So it will be average value is 1.63 meter per second square. Then you can find the weight equals to, mass will not change. The value of acceleration due to gravity is 1.63. That gives you weight equal to 3.26 Newton. So mass remains same everywhere, at the top of the Mount Everest, sea level, at any point on the Earth's surface, or at any point on the moon surface. But the weight of the same object will change depending on the value of G. You can practice some multiple choice questions, but try to explain if you choose any answer. Okay. Similarly, you can try this question.